Okay, what we want to talk about in this lesson set 29 is unit circle. We're going to talk about very large and very small angle measures and what they approach, and then we're going to talk about quadrantal angles. We're going to talk about what is the measure of sine, cosine, tangent at 0, 90, 180, 270, and 360. Okay, first of all, colleges will push the unit circle. And the unit circle is how they want you to think about sine, cosine, tangent. The unit circle, if you have to create it at college, can just be done with your fingers. You already know that trick. So just a little bit about the unit circle. What the unit circle says is that you're going to draw a circle, and I apologize, these are not drawn very well. 30, 60, are not, splitting the quadrant in thirds, but I think you're going to at least get the idea of what we are working with. If we were at school currently, I would have a nice handout for you and we would be filling this in together. But okay, so if you were to take a unit circle, what it says is you have a circle with the radius equal to 1 unit. And if the radius is equal to 1 unit, then you get a triangle that is created. And we're going to know that if this is 30 degrees and the radius is 1, then what are the values of x, which is on the horizontal axis, and y, which is on the vertical axis. Now to do that, we know that you could deal with sine, cosine, and tangent in order to find those values. So the first thing we're going to look at is I'm just going to mark these in terms of degree and in terms of radian measure, and then I think we'll go down to the bottom one and actually put the sine, cosine values for them. So if we were to mark these in degrees, just like we do with our finger trick, we know we have 30, and then we have 45, and we have 60 degrees. Now, if we continue on, we have talked about that bow tie effect. So envision that this is going down where this is a 30-degree angle. If you were to talk about that, you're 30 degrees short of 180 degrees. So that means that this measure would be 150 degrees. Or you can take 180 plus 30, and this would be 210. We know that we have our 90 degrees, we have 180, we have 270, and we have 360, which is also 0 degrees when you start out. If you talk about 30, we could just count around, so you have 30, 60, 90. If you go another 30, you are at 120, another 30 is 150, another 30 is 180, another 30 is 210, another 30 is 240, another 30 is 270, I know I had 27, another 30 puts you at 300, another 30 puts you at 330, and then you are at 360. The other thing you can do is count your 45-degree angles. So you have 45. If you go another 45, you are at 90. If you go another 45 degrees, that puts you here at 135. If you go another 45 degrees, you're going to be at 180, which I already have marked for us. You go another 45 degrees, and that puts you here at 225. If you add 45 again, you are going to be at 270. If you add 45 again, this is 315 degrees. And you add 45 again, and you're back to 360. So those are the actual degree measures in a unit circle. Now, as we talk about a degree measure, we could talk about what a radian is. A radian is going to be the angle that's created when you take the radius of the circle and lay it on the circumference of the circle. So if you talk about circumference of a circle, circumference of the circle is the same thing as 2 pi r. And I know that the circumference being 2 pi r, that means that the radius will go around it 2 pi times. So 2 pi is going to be the same thing as 360 degrees because the circumference of a circle all the way around is 360 degrees. So we know this. 2 pi radians, the same thing as a radius, that is the circumference of the circle. So 2 pi radians, and I shouldn't have set it up as a railroad track yet, 2 pi radians is equivalent to 360 degrees. Now if you divide both of those by 2, we know that pi is the same, pi radians is equivalent to, you could put the equal sign if you wanted to, divide both these by 2, and you get 180 degrees. So if I talk about this circle, I know that in my circle, this 360 is the same thing as 2 pi. I know that 180 degrees is the same thing as pi. If I talk about half of 180 degrees, that is 90 degrees. So I could go ahead and divide pi by 2, and 90 degrees would be the same thing as pi over 2. If I want to convert that over, I have 90 degrees, and I want to know how many radians is that. Well, I know that 180 degrees is the same thing as pi radians. And if you do that, 90 goes into 180 2 times, so I know that 90 degrees is equal to pi over 2 radians. Or I just keep going by a half. So I have 0, I have a half pi, This 270 would be the same thing as 3 pi over 2 and 4 pi over 2. So you have 1 pi over 2, 2 pi over 2 reduces down to pi, 3 pi over 2, and 4 pi over 2. 4 pi over 2 reduces down to just 2 pi. Think about 30 degrees. If I look at 30 degrees and I want to know what is that in terms of radians, we have pi radians is the same thing as 180 degrees. 30 goes into 180 6 times. So 30 degrees is the same thing as pi over 6 radians. I go another 30 degrees, and that's going to be 2 pi. I could talk about 60 if I wanted to, or I could just keep adding pi over 6 for every 30 degrees. So if I talk about 60 degrees, and I want to convert that over into radians, I know this. Pi radians is 180 degrees. 60 goes into 180 degrees 3 times, so it's pi over 3 radians. Well, if I look at it, I have pi over 6. Pi over 6, if I double that or add another pi over 6, you are at 2 pi over 6, but 2 pi over 6 reduces down to pi over 3. So this is the same thing as pi over 3. It's 2 pi over 6, and then I add another 30 degrees, and that's 3 pi over 6. Well, 3 over 6 reduces down to 1/2. This is the same thing as 4 pi over 6. I go another 30 degrees, and I am at 5 pi over 6. I go another 30 degrees, and you are at 6 pi over 6. Then you are at 7 pi over 6, 8 pi over 6. This would be 9 pi over 6. 300 degrees is another 30, so you're at 10 pi over 6. Another 30, you are at 11 pi over 6. Another 30, you are at 12 pi over 6. Now I put those in pencil because if I reduce 4 pi over 6, 4 over 6 reduces down to 2/3. Maybe I can just write it over so I don't have to write it all the time. This remains as 5 pi over 6. 6 pi over 6 reduces down to just pi. This is 7 pi over 6. 8 pi over 6 reduces down to 4 pi over 3. Then you have 9 pi over 6. 9/6 is the same thing as 3/2. 10 pi over 6 reduces to 5 pi over 3. If I go to the next one, we're going to have 11 pi over 6, and then 12 pi over 6. 12 over 6 is 2, so you get to 2 pi. Now on top of that, we have the 45 degrees. So if pi is 180 degrees, 45 is a fourth of that. Or it's half of 90 degrees, and 90 degrees is 1/2 pi, and half of that is 1/4. So this would be pi over 4. This would be 2 pi over 4, and 2 over 4 reduces down to 1/2. So you have pi over 4, 2 pi over 4. This is 3 pi over 4. Then you have 4 pi over 4, which is 1. Then I have 5 pi over 4, 6 pi over 4, but 6 over 4 is 3/2 pi. Then you have 7 pi over 4 and 8 pi over 4. So there are the degree measures and the angle measure, or the radian measures of your unit circle. I think I'm going to have to stop and then go back and fill in sine cosine values for your unit circle.